Howdy folks. Following the previous video, I did discussing or doing more of an overview of a little bit of my work mining through X-ray timing data for measurements of pulsar spin frequency, or at least evidence of pulsar spin frequency or oscillations. I figured the next best thing for me to do would be to do as close to a live demonstration working through my process of actually like doing this mining, because I got a couple of questions with the last video, and so I figured with this video what I'm going to do is I'm going to record the process of mining through data from a new source. I haven't gone through and mined through any data from this source yet, and it's also a relatively newly discovered pulsar. So what I'm going to be mining through here, as you can see, is that there's a nicer discovery that the SRGA J144459.2-604207 is an accreting millisecond pulsar by all of these wonderful authors. Hopefully some of those names are familiar to plenty of you. I know plenty of them are, to me at least. There's also this other paper that was from April 2024, except that it's just in preprint still. And these are just here on ADS. I'll, of course, leave links to both of those ADS pages below so you can find those different papers. I'll also leave citations in the description of the video, but I think those links will probably be a little bit more useful to you. So that's the source that we're going to be looking through right now. Obviously, I'm not going to show those actual papers because they're copyrighted and whatnot, and I don't want to, show the content of those. But go check those out. Go read them. I've read through them a little bit by now. And basically, what I'm going to be trying to do for you in this video is just document my process of looking for evidence of spin frequency, or at the very least oscillations, for that SRGA source. I'm just going to call it SRGA because otherwise it's a bit of a mouthful. If we look back at the abstracts of both of these, you can see that this one here from IOP is saying that it is a 447.9 hertz signal, and with this other paper right here, it's saying it's 447.8. But the first thing that I need to do is I need to get all of this data here. So I'm over here at the HEASARC, and just in the browse section, and what you're hopefully seeing right here is that we're in the nicer master catalog, and I've dropped the SRGA because for whatever reason that SRGA didn't want to resolve in the browse search, so we just have this part right here. But you can see there's like 46, I think it was 46, I don't know, it's 45, 46, something in there, different OBS IDs. Some of them are zero exposure, so I'm not going to be going after these. And actually, that one's cycle 7. Almost all these that are in cycle 6, I'm going to go after. Now, let me actually preemptively state that I am going to be processing or preparing this data with HEASOFT 6.33. I know I did a video a little bit ago encouraging everybody to upgrade to HEASOFT version 6.34. But on this particular machine, I realized, like, once I started recording this, that I'm using HEASOFT version 6.33, and I don't feel like upgrading. I'd much rather just mine through this and, see what kind of results we get with HEASOFT 6.33. I'll upgrade to HEASOFT version 6.34 after the fact, so I know that I'll probably be perfectly fine if I end up using HEASOFT 6.33, so just throwing that out there. So here we are in the terminal. Let me beef up the font here one time for everybody. And I'm going to be using Auto Nicer, but before I do that, I'm going to run NI geodown to get the latest geomagnetic data. Okay, so that ran pretty swiftly. And then what we're going to do next is we are going to start up Auto Nicer. Okay, so it's looking for our target, and I should have stated that I'm working on a drive and in a directory where I'm specifically going to put all of this data for the SGRA source. So I'm going to go back over here to the archive, and we're going to grab just this J144459.2, all of this. If I could just grab it all completely. There we go. and we'll stick that into the target field of AutoNicer. I'll get rid of that last little bit of white space. That probably won't be a problem as long as it resolves with the HEASARC, so we'll do that. Yes, we want to apply barycenter correction. I want to compress everything that's not the barycenter corrected MPU7 cleaned event files, so yes, that is there. No output log, and we'll just wait and see that this resolves. Okay, so we've got the AutoNicer prompt here, and what I'm going to do right now is we are just going to go back, and I could select these OBS IDs one at a time, but it looks like almost all of these that I'm interested in getting, actually all of them are cycle 6, so I'm just going to tell it to grab everything from cycle 6. It will it's added all of these OBS IDs to our queue of OBS ID datasets to be retrieved and reduced using NiCR L2 with the following command on the screen, as just how it's going to get pumped through NiCR L2, and then also it will do the barycenter correction, since up here we told it yes, do the barycenter correction, and the barycenter correction command is what you're going to be seeing on the screen right now. I'll overlay it in post, obviously. So, and we're going to just let AutoNicer do its thing now. So we're just going to type in done, and it is starting to grab everything. We'll just let this one download really quickly. I'll speed up whatever goes on here. Okay, and you can see now NiCR L2 has been engaged. After we retrieved everything, it's going to run through, everything that it will normally run through in NiCR L2. Right now, you can see we're running NiCR Cal, and then, again, it'll just go through everything and then do that barycenter correction out at the end. Okay, so AutoNicer is going to process every single one of those OBS ID datasets in series, meaning that it's just going to go grab one and then prepare it with AutoNicer, do the barycenter correction, move on to the next one. It's just going to spit everything out into the bucket, which is that directory that you saw me working in. And so I'm going to let that run for a little while based off of the bandwidth speeds. Shouldn't take more than maybe like 1 or 2 hours, and I'll come back in 1 or 2 hours and see, that hopefully all that is there, and, we should be able to start mining through all that data once it's ready to go. Anyways, we have gone ahead and retrieved everything with AutoNicer. We'll just take a look right here. I did manually go out and I purged a couple of these different OBS IDs that were at 0 exposure, just because it didn't really serve much of any purpose for me. So that is pretty much the entire first stage. That's just gathering all of the NiCR data and preparing it. Again, I did that with HEASARC version 6.33, but now we're going to move on to actually kicking off the mining of this data now that we've collected all the material that we need. Alrighty, so I've navigated to a different directory now that I'm working in, just specifically for this SRGA source, and I'm using some custom software that I've written for myself that does all the ZN squared processing, or in this case we're just going to use Z1 squared, although reading through one of those papers, it appears that the authors are using a variety of different ZN squared values, but I think they're going like Z2 to Z4. I'm not sure. Again, I'll refer you to those papers. But I'm just going to be doing Z1 squared. It's just good. That's good enough for me for the time being, just to see what exists in these data sets. What I'm going to do is I'm going to quickly show you how that code works. That code is called Time Wrangler, and Time Wrangler is closed source. Unfortunately, at the moment, I'm choosing purposefully to leave it that way, just because I don't think it's in a state that I'm comfortable with other people using it yet. But anyways, we're going to call Time Wrangler, and then I'm going to pass in this database flag, and we're going to name it. Alright, and then it's just going to get the name.twdb for Time Wrangler database, and we're going to tell it to create it. Alright, it's going to ask us for the source, which is just rather conveniently this, whatever resolved from the HEASARC from before. And and we just want the nicer stuff. So it's just going to create this database here for us. All right, and as you can see, we have a database, and what we're going to do now is I'm going to fill this database with references to all of the event data. Okay, so we've got our database there, and then we're going to tell it to fill and look for event data or event files there. So we're going to just run this really quickly. Okay, and our database should be populated. Okay, and just as a reminder, it's 447.9 is one of the reported values, and the other one is 447.8. So I'm just going to look at, let's try 447.75 to 448 at a microhertz resolution is what I want to do. So here we're going to go call Time Wrangler database, and then we're going to pass in that database name, and then we're just going to tell it to mine. We're going to give it 1e-6 or 1 microhertz resolution, and we're going to go 447.75. Let me just double check that is correct. Yep, 447. That's what I ended up saying. So 447.75 to 448.0. And now we're just going to let this churn through and do its thing. This is just doing Z1 squared along with the pulse profile and everything. This progress bar that you're seeing right now is the progress bar for Z1 squared. Each one of these iterations represents a different value for new, and we're just going to let this kind of roll through and see if we find anything by the time this is done. And so this is just, obviously, again, just for this one OBS ID where you've got the 32 to go through. And since it's about midnight and I've got plenty of stuff I need to do tomorrow, I'm just going to let this run overnight. It's probably not going to take too long because, actually, after all, you can see right here, this one, we didn't find anything in here anyways. There's no measured spin frequency in here. Z1 squared, that should be Z1 squared, but I didn't add enough in there. So we passed different processing mode. We'll get to the different modes in a moment, but you can see that these are churning through pretty quickly. We're doing 250,000 iterations, and we're actually running pretty quickly here. So this is very likely going to be done, far before I wake up, probably actually even in like the next hour. But I'm just going to let this stuff run through, and tomorrow, the next day, we will go through and we'll look at the different results and see if we got anything of any interest. Alrighty, folks, so it is 2 days later, and yesterday morning I checked and saw that the mining and everything was complete for the 30-some event files that I had mined through for this SRGA source. I am just doing something with it now, 2 days after the fact, because life gets in the way, of course, and, I'm getting to do that now. I've loaded it into a local version of the web archive that I have for this, so we'll be able to take a look at it, and by the time you see this, you will be able to access these results at the link in the description of this video. You can see that I've got a number of these sources here still, but I've added in this SRGA source. I'm going to need to figure out how to get that SRGA in this top line here, just as a weird bug fix. But as you can see, hopefully we got 8 results with that nicer data. And so what I want to do now is I'm going to walk you through that third stage that I went through, where we're just going to filter out this data set. It's not going to take too long because there's only 8 results, and that's honestly kind of really nice because it's a real easy, simple way for me to demo my process and kind of what I'm doing right now. So let's go ahead and let's look to start filtering this. Okay, so back over here in the web dashboard or the archive, you can see we're in the with the SRGA source. Here's our 8 results. This is what the ephemeris looks like right now. It's not super clean. As you can see, like here's one result that's kind of like way out of here. And then there's this one, which is a bit of a weird one. So we're going to look to filter some of this. And you can see right here that in our data table we have got a full mode and then a GTI mode. And what we're going to look to do here is just filter these. I'll explain what the full mode and the GTI mode are as we kind of go through. But as you can see right here, this first result is really, really noisy, really choppy, not good at all. And so what I'm going to do right now is I'm just going to come over here to the Timing Evolution Filters tab, drop that down, and we're going to filter out this first result ID and just get rid of it. And so if we go back up to our table, you can see now we only have 7 results, and that one is filtered out. But I'm quickly going to add that back in because you can see that that one is in what is considered full mode, or what I consider to be full mode. Now, what exactly is full mode versus GTI mode? I have a little bit of an explainer here with this drop down on more info on individual results. And as you can see right here, we have a light curve from some nicer data. And you can see that there are 3 different exposure intervals in this observation. So you can see that NICER was collecting data or collecting light from the source during this first exposure, and then it stopped and trailed off. And that's of course, because NICER is on the ISS and is orbiting around the Earth, and so it's never going to be able to look at the same source, continuously just for a very long period of time. There's going to be blocks in there where it's not able to look at the source in question, and so that's that's why there's those gaps in between. But going back to this here, so we've got these 3 different exposures, and with these 3 different exposures, there's what I call the full mode and the GTI mode. Now the GTI mode is pretty simple. It's where I'm chopping up the entire MPU7 or Barry Center corrected MPU7 clean event file into these different exposures, and I'm just analyzing the light, or analyzing the data, the photon arrival times that is, from each one of these intervals individually. Whereas if something is processed in the full mode, I'm taking the entirety of the data set and I am just ramming all of the arrival times, regardless of which exposure they are in, through Z1 squared. And the reason why I'm doing that is because for sources, at least in my experience, for sources with really, really sparse data, I've found that I actually do find some type of result when I just ram through all of the data. But for sources, of course, like the crab and whatnot, that doesn't work out as well. But for sparse data, I at least like to go through and see if there's even just any evidence at all of any type of evidence of oscillations there. And so by ramming all of those photon arrival times through, I can basically just see, is there something in this data set? And then if so, what my code does is it breaks down everything based off of the different exposures. That it'll cut up the whole data set into each one of the exposures and process each exposure individually. And so if we come back up here, that's what you're seeing when you see full or GTI. So you can see, like right here for this OBS ID 6204190103, you can see that we have a full result plus 2 GTI results. And then here's another one, we've got a full result plus 2 GTI results. And then this one right here has a full result and then a GTI result. There's also some written notes on explaining this, so check out this drop-down tab for more info on individual results. But yeah, like with this result ID number 1, it's in full mode, and a lot of times in the full mode you're going to get really noisy results like this that just aren't really good. Like the Gaussian fit to this just is crap as well. So we can just go ahead and throw that away, and we'll do that with this result ID exclusion, and we'll add that to what is being excluded. You can see it's filtered out, and then it's filtered out up here at the top. So let's go ahead now and look at result ID number 2, and you can see this is actually quite a nice result. Let's zoom in on this. This is a nice Gaussian shape. You can see the Gaussian fit to this is pretty clean. There's a little bit of noise on either end of the the main Gaussian shape, so to speak. But still, I consider this a pretty good result. Z1 squared value of about 70. So this is a good result that I would consider to keep in here. And if we look at the phase resolved light curve, you can see that there's a little bit of wiggle going on in here, but there's not a lot. So I probably wouldn't say this is evidence of pulsation. Rather, simply just from this plot right here. We've got evidence of oscillations. Okay, so we'll keep that result in there. Result number 3. This one's a little bit trickier because this one has a Z1 squared value of approximately about 30. Let me just double check on that. You come up here and you can say that, yeah, so it's just barely over 30. Not really a clean, nice peak like we saw before. For the time being, I'm going to leave this in because I want to keep a look or keep an eye on it and compare it to some of the other results for the moment, because it's not too far off, but the phase resolved light curve or pulse profile doesn't really have anything in there either. So we'll keep that there for a moment. We might come back to filter that out. Moving on to this one, result ID number 4. There's absolutely nothing here. That's just a really bad result again because it's kind of that full result. Moving on to number 5, though, you can see we kind of have something Gaussian-like trying to show up in here. You can see obviously a lot of noise. It's a weaker result with just barely over 30. So we'll leave that. Again, I don't think for any of these phase resolved light curves we're really going to get a nice clear picture of the pulse profiles. Looking at number 6, though, this one's actually really nice, though. So this one's in a much nicer shape, of course. The Gaussian fit is also really, really nice. Z1 squared value greater than 40. Let's actually take a look up at that row ID number 6. 44.487. So there's a good deal of evidence there with that one. So we're going to keep that in. Again, looking at the pulse profile, not really anything here. There's not many arrival times to kind of go off of with that. So still a decent result, though. I'll leave that in for the moment. Let's go over to this last obs ID, and here with this full result, I mean, this is really, really choppy. You can see from the pulse profile that we're dealing with tens of arrival times, so very, very sparse data here. It shows that there's something kind of in here, but it's not really clear or coherent at all. So we're going to filter that out. Actually, before I filter that out, let's look at the second result. Yeah, this is kind of a similar thing right here. So after we kind of chop off a little bit more of that, you can see that we're finding something here. The evidence, the Z1 squared there is, there's evidence for something there. And maybe this isn't something worth completely throwing away, but to build an ephemeris for the source, you can maybe see also a little wiggle going on with this, but again, we're dealing with tens of arrival times. So I think I'm just going to throw away this entire OBS ID, and we're just going to filter both of those out. So we're down to 4 measurements, and this is kind of what it looks like. And you can see here's an outlier with quite big error bars. So realistically, this, if we go back here, result ID number 2. This is probably our cleanest and best result. It probably has the most wiggle in the pulse profile. Definitely the strongest statistical evidence through Z1 squared here, with that being like well over 70. So I'm pretty comfortable saying that I've confirmed at least evidence of oscillations for this SRGA source, which is pretty cool to me. I mean, that's good enough for me to say, confirmation evidence of oscillations. There's possibly some more work that I could do with regard to cleaning things up to try to confirm evidence of pulsation with that pulse profile. But just taking a look at what we have right here, I think this is good evidence of, at the very least, evidence of oscillations. I mean, there's at least evidence at 447.9 hertz, as was put out in this paper, and they're using a very similar but much more advanced methodology than I am with regard to Z1 squared. Honestly, this one right here could probably get filtered out because it has very weak. This one right here, row ID number 3, could get filtered out. And so really there's just 3 of these data points here, and that's actually much nicer. You can see we're at 447.969, and it's just kind of gradually going down. These error bars are not necessarily the best. You can see we're on the order of, what is this one? So we did it at microhertz resolution, so it's 494 microhertz error. This one 1.3 millihertz error, and then this one is almost a millihertz error, or error bars, if that's what you want to call it. You could also go off the fit Gaussians. That's why I have these fit Gaussians in here, and you can see also the exposure for each one of those, and then the arrival time. So like with this result right here, this is actually a stronger result than what we had before, but you could see that we've got much less exposure, although comparable number of photon arrival times in here. That's what this ATS column is. So anyways, that is just a quick demo, or as close to a quick demo as I can do, of my process mining through the data from one of these sources. That was step 1, 2, 3. Just gather everything, put it through Z1 squared, and produce those pulse profiles. And then with this last stage, again, it's kind of more of a manual review, because it takes a little bit of, I don't want to call, so it's not subjective, but it kind of is, as long as you have a good bit of predefined, I don't know what you want to call it, conditions, I guess, for deciding what stays and what goes. Obviously with one of those results, it was like a 30 ZN squared, so the statistical evidence was there for oscillations, but the shape was just not really a clean Gaussian at all, or not, just a nice clean bump right there, as we would want to see with some of those other, like we got with some of those other results. So I just threw that out. It's up to you. You can go to the web dashboard and just filter things out for yourself. That's why I've put it there, and you can even download your filters. So if we go back here, you can see, of course, as always, you can download the unfiltered data or the filtered data. That would just be this table right here that you're seeing. And then you can also come down here and you can download your settings for the filters that are in this timing evolution filter drop down. And if you don't want to even see the table, you could just get rid of the table. But I like seeing the table, and so that's why by default it's there. So anyways, that's the whole process. If you have any questions, comments, or concerns, don't hesitate to reach out and let me know. But we'll definitely discuss a lot more on this topic. For some of the other sources that I've done in this, I've just figured this is a good way of demonstrating at least the basics of my process going forward. So, yep, thanks for watching, and I'll hope to see you all again next time.